Dear students, today we will see about microprocessor. First, let us see architecture of 8085 microprocessor. A microprocessor is fabricated on a single integrated circuit or chip that is used as a central processing unit. The 8085 microprocessor is an 8-bit microprocessor that was developed by Intel in mid-1970s. It was widely used in the early days of personal computing and was a popular choice for enthusiasts due to its simplicity and ease of use. The architecture of the 8085 microprocessor consists of several key components, including accumulator, registers, program counter, stack pointer, instruction register, flag register, data bus, address bus, and control bus. Now see the layout diagram. Here you can see various blocks: accumulator, temporary registers, flag flip-flops, arithmetic logic unit ALU, and instruction register, instruction decoder, and in the right side you can see multiplexer and various temporary registers like W, Z, B and C, D and E, H and L temporary registers. They are all 8-bit registers, but when combined it can work as 16-bit register. Here W and Z registers cannot be used by us. It will be used by only system. Then you can see stack pointers at the bottom and program counter, increment, decrement, address latch, address buffer, address data buffer. And in the above the diagram, you can see interrupt control, serial input output control. And at the bottom of the microprocessor layout, we have shown timing and control device. Next, let us see the components one by one. First, the accumulator. The accumulator is an 8-bit register that is used to store arithmetic and logical results. It is most commonly used register in the 8085 microprocessor and is used to perform arithmetic and logical operations such as addition, subtraction, and bitwise operations. Features of 8085 microprocessor. The 8085 microprocessor has 6 general purpose registers B, C, D, E, H and L, which can be paired, as I already told you. BC, DE and HL can be paired for 16-bit operations. The program counter, simply called it as PC, is a 16-bit register that holds the address of the next instruction and increments after each instruction execution. Stack pointer, simply called it as SP, is a 16-bit register that keeps track of the top of the stack, used for storing and return addresses and temporary data. The instruction register is an 8-bit register that holds the instruction currently being executed. The flag register is an 8-bit register that stores status flags, including carry, that is set when an arithmetic operation generates a carry. Next is 0. It sets when the result is 0. And next sign flag, it sets when the result is negative. And parity black, it sets when the result has an even number of ones. The data bus is an 8-bit bidirectional bus that transfers data between the microprocessor and memory or other devices. The address bus is a 16-bit unidirectional bus that specifies memory locations and devices the microprocessor accesses. The control bus consists of signals that manage microprocessor operations including read, that is to fetch data, write, that is to store data. Similarly, interrupt to signal an external event and reset to restart the microprocessor. Next, we will see Arithmetic and Logic Unit. It is used to perform mathematical operations like multiplication, addition, subtraction, division, decrement, increment, etc. Different operations are carried out in ALU. Logical operations, bit shifting operations, and arithmetic operations. Flag register. It is an 8-bit register that stores either 0 or 1, depending upon which value is stored in the accumulator. Flag register contains 8 bits, out of which 5 bits are important, and the rest of 3 bits are don't care conditions. The flag register is a dynamic register because after each operation, to check whether the result is 0 or positive or negative, whether there is any overflow occurred or not, or for comparison of two 8-bit numbers, carry flag is checked. So for numerous operations to check the contents of the accumulator, and from that contents, if we want to check the behavior of the given result, then we can use flag register to verify and check it. So we can say that the flag register is a status register and is used to check the status of the current operation which is being carried out by ALU, that is Arithmetic Logic Unit. Different fields of flag register are naming the flag register. I already told you 5 flag registers we have seen. What are they? Carry flag, parity flag, auxiliary carry flag, zero flag, sign flag. Accumulator is used to perform input, output, arithmetic and logical operations. It is connected to ALU and internal data bus. The accumulator is the heart of the microprocessor because for all arithmetic operations, accumulator's 8-bit pin will always they are connected with ALU, and in most of the times all the operations are carried by different instructions that will be stored in the accumulator after operations performance. There are 6 general purpose registers. These registers can hold 8-bit values. These 8-bit registers are B, C, D, E, H, L. These registers work as 16-bit registers when they work in pairs like B, C, D, E, and H, L. Here registers W and Z are reserved registers. We can't use these registers in arithmetic operations. It is reserved for microprocessors for internal operations like swapping two 16-bit numbers. We know that to swap two numbers we need a third value. Hence, here WZ register pair work as a temporary registers for such operations, and we can swap two 16-bit numbers using this pair. Program counter. Program counter holds the address values of the memory to the next instruction that is to be executed. It is a 16-bit register. For example, suppose the current value of the program counter, say PC equal to 4000H hexadecimal. It means that next executing instruction is at location 4000H. After fetching this program counter, always increments by +1 for fetching of next instruction. Next slide, stack pointer. It works like a stack. In stack, the content of the register is stored that is later used in the program. It is a 16-bit special register. The stack pointer is a part of memory, but it is part of stack operations unlike random memory access. Stack pointer works in continuous and part of the memory whereas program counter works in random memory locations. This pointer is very useful in stack related operations like push or pop and nested call requests initiated by microprocessor. These three are commands: push push, pop pop, and nested call call. These are commands. It reserves the address of the most recent stack entry. Temporary register. It is an 8-bit register that holds data values during arithmetic and logic operations. Instruction register and decoder. It is an 8-bit register that holds instruction code that is being decoded. The instruction is fetched from the memory. Timing and control unit. The timing and control unit comes under the CPU section and it controls the flow of data from the CPU to other devices. It is also used to control the operations performed by the microprocessor and the devices connected to it. There are certain timing and control signals like control signals, DMA signals, reset signals, status signals. Interrupt control. Whenever a microprocessor is executing the main program and if suddenly an interrupt occurs, the microprocessor shifts the control from the main program to process the incoming request. After the request is completed, the control goes back to the main program. There are 5 such interrupt signals in 8085 microprocessors: INTR, TRAP trap, RST 7.5, RST 6.5, and RST 5.5. Priorities of interrupts. TRAP trap interrupt has more priority, more powerful than other interrupts. So I tell you in descending order: trap, RST 7.5, RST 6.5, RST 5.5, and INTR. So least power having INTR interrupt and TRAP trap interrupt has more priority. Address bus and data bus. The data bus is bidirectional and carries data which is to be stored. The address bus is unidirectional and carries the location where data is to be stored. In 8085 microprocessor, the address bus and data bus are two separate buses that are used for communication between microprocessor and external devices. Address bus is used to transfer memory address of the data that needs to be read or written. Address bus is a 16-bit bus allowing 8085 microprocessor to access up to 65,536 memory locations. The database is used to transfer the data between the microprocessor and external devices such as memory and input-output devices. The database is an 8-bit bus allowing 8085 to transfer 8-bit data at a time. Data bus can also be used for instruction fetch operations where microprocessor fetches instruction code from memory and decodes it. The combination of address bus and data bus allows 8085 to communicate with and control external devices, allowing it to execute its program and perform various operations. Serial input and output control. It controls the serial data communication by using serial input data and serial output data. Serial input-output control in 8085 microprocessor refers to the communication of data between microprocessor and external devices in a serial manner, that is, one bit at a time. The 8085 has a serial input-output port, simply called, short form SID/SOD, for serial communication. The SID pin is used for serial input and the SOD pin is used for serial output. The timing and control of serial communication is managed by 8085's internal circuitry. The 8085 also has two special purpose registers, the serial control register and the serial shift registers. While calling, serial control register is called as SC and serial shift register is called as SS, which are used to control and monitor the serial communication. Next, we shall see the 8085 microprocessor applications. We can use it in the embedded system. The 8085 microprocessor is commonly used in embedded systems such as industrial control system, automotive electronics, and medical equipment. In computer peripherals, the 80 microprocessor has been used in a variety of computer peripherals such as printers, scanners, and disk drives. Similarly, in communication system also it is used in a variety of applications. The 8085 microprocessor has been used in communication systems such as modems and network interface cards. In instrumentation and control systems, the 8085 microprocessor is commonly used in instrumentation and control systems such as temperature and pressure controls. The 8085 microprocessor also used in home appliances. The 8085 microprocessor is used in various home appliances such as washing machine, refrigerator, and microwave ovens. And one more application we can see is educational purposes. The 8085 microprocessor is also used for educational purposes as it is an inexpensive and easily accessible microprocessor that is widely used in universities and technical schools. Thank you.